This is Math 8, Section 6.2, representing functions. So to do this, first we're going to take some verbal descriptions and put them into different forms. So for example, it says Janice plans to enroll in a Spanish class in language school. She has to pay a registration fee of $100 initially, plus $20 multiplied by the number of hours because she works, or $20 for each hour-long session. So the relation between the total amount she pays and the number of hours is represented a little bit like this. So if we transfer this into an equation, it would look like plus 20x. Okay, and then we could say that y is equal to this because y is what we are trying to find, which is the total amount of money. Total money. And this here, hours, is x. So here we have it written as equation. Now we could think of x as the input because we're going to figure out how many number of hours first. And then once we put in the number of hours, for example, 1 hour is 1 times 20, which is 20 plus 120. And that would give us our output, the total amount of money, which is that. Okay. As a table, so we could write 0. So otherwise she has gone 0 hours. Then y is going to be 100 because we put 0 in here, and we get y. When x is 1, y is 120, 2, 140, and 3, 160. That's how you write it on a table of values. Now to put it in a graph, it'd be easy because we already know the inputs and the outputs. So we could simply write it on the graph this way. And we have a little zigzaggy here because our first line is 100. We're going to do 120, 140, and 160. 1, 2, 3. This is time in hours. This is amount in dollars. And this whole thing is paid for Spanish. Okay, so we graph 1, 2, at 0, it's 100. 1, it's 120. 2, it's 140. 3, it's 160. So there we get our line, and that is how you can represent it as a line. This is a linear because as it's represented by a line here. Okay, let's try this in an example. A says, write a verbal description of the right algebraic expression for the function. So a tank contains 8 gallons of water. And water is then pumped into the tank at a rate of 2 gallons per minute. So plus 2 gallons per minute. Alright, the amount of water in the tank, y gallons, is a function of the number of minutes that the water has been pumped into the tank. Minutes is x. We know that the total money is going to be y. So we have description here. We can put an expression. 8 plus x equals y. And that is our. B says construct a table of values. So we put 1, 2, and y is going to turn out being 12 and 14. Okay, in this equation, if you 2, 1, 8, x is 1, so then y would be 10 because 2 times 1 is 2, plus 8 equals 10. You could do the same thing with 2 and 3 and y would equal the other two values. That's how we get those. C says use, graph, sorry. So water in tank is our title. Time, minutes is the x-axis, and water gallons is the gonna skip up here to 8, 10, 12, and 14, 2, and 3. Is 1, we're up at 10, 2, we're up at 12, 3, we're up at 14, and there we go. That is also linear. Try this in guided practice 1, 2, and 3. Last example, 6, and we are table values for a function into a graph. So Rachel starts cycling at a distance at a constant rate. These are distance from home as a function of the time she takes to cycle. So as she's moving along at 0 time, she is already 6 meters away. So she must have already started 6 meters away. When she is 1 second, she's already gotten 10 meters away. 2 seconds, 3, 18, 4, 22, and 5, 26. Now, as we construct this graph, which will be the easy part, I'm going to write the expression. Our break-even point will be something useful to help us figure out how to do this. So if we want to graph it like this, and represent these as 6, 10, 14, 18, 22, and 26. Down here, I'm going to represent them as 1, 3, 4, and 5. So as we go to 1, we get 0, we are at 6. Remember, 1, we're at 10, we're at 14. 3, we're at 18. 4, we're at 22. 5, we are at 26. We get this linear function. And in order to write a linear, it's going to be in the format of y equals mx plus b. Well, remember, intercept. And where did she start? Remember our break-even point, you start at the startup cost? Well, here, you are starting at 0. That's the y, and it's going to be 6. M is slope. So we can see that it's positive, no, it goes up. The rise, for it goes up, it goes over 1. So that's going to equal 4. Remember, it's positive. We know b, we know m, so we can translate this equation into x plus 6. And that's how we write it. That was B. C says, describe how the slope and the y-intercept are related to the function. So, intercept describes where it's, right, because that's where she was at 0. And that is B. And then our slope of M describes her rate of speed. Now if it would have been sloper or steeper, been going faster. If it would have been shallower, she would have been going slower. So the slope tells us how fast she was actually going. Go ahead and try that in guided practice. 3.